Let's check the machine settings first. Right click on the machine. Under settings, go to the network and check the adapters. First is net, second is host only, and third is network, which I configured, that is host only adapter, third adapter. And same way on compute machine, compute and controller, both machines under networking, we are using 3 adapter cards. First is NAT, second is host only. Alright, and this is my NAT adapter. Now once the adapter is configured, let's check the machine. This process is all about the settings. Go to the config file, cd config. Under config, this is the Openstack file where you will see the IP addresses of the machines. Now this is the list of files, the scripts which we created, and the credentials file have all the passwords and the username which will be used throughout this deployment. Admin user, this is a role member, then we have admin username is admin password is admin pass, and for every service you see the username and password. Like for a Cinder admin, the Cinder DB user and Cinder user is the Cinder DB pass. All other services the username and passwords. Glance DB pass, glance password heat, keystone, neutron DB pass, and neutron password. The password which will be used in my scripts are taken from this file, credentials file. This is placement, and this is my project name, a demo project. Now let's look at the different path. This is the path. In my home directory, this disk directory and image directory and ISO directory is /img. Configuration directory is /config. Library directory is lib. Then the other directories. Look at the cluster file, the sequence of scripts which we will be using. So first thing is we have this etc host file which is configured right at the time of installation. Now I will start from here. Yum install MySQL, rabbitmq, memcached, then keystone, then we have keystone auth token, then we have glance. This is going to be the sequence of the scripts. Then we have placement and all. Let's go to the script directory and let's call the scripts one by one. This is admin openrc, where my credentials or the environment variables are set and exported so that I can work with Openstack command line utility. I go to the scripts directory, cd scripts, CentOS, because we are working in CentOS 8, and these are the scripts. Let's start with yum install MySQL, memcached and rabbitmq. So we'll start with the first. Let's look at yum install MySQL. So this is installing MySQL. After installation is done, it will create a separate configuration file for OpenStack under etc my.cnf.d 99-openstack.cnf. Let's look at this file first. Just take a look. We have executed it. Installation is already complete. Let's look at this file. First we source the configuration path, credentials and functions under library. Then we see the host name, and then installing MariaDB server, MariaDB, Python 3 MySQL, py MySQL, and then after installation is done we are starting it, and then we are setting it, like we are logging into MySQL-u root, and then executing this use MySQL database update user plugin. We are removing the plugin where username is root, update user, set password which I wanted to set, and flush privileges. After that, we are just verifying that it is working fine. MySQL-u root, and then we are setting this file etc my.cnf.d 99-openstack.cnf, and we require these settings: default storage engine, InnoDB per files per table, max connections, and all this stuff. And finally opening the firewall settings. Let's check that rabbitmq file, MessageQue message. So first, same step, sourcing the files and installing the rabbitmq server, policy core utils, and check policy, then enable and start and enable firewall port. We also require policy for security enhanced Linux. Let's create the policy. So this is the script which is creating a file rabbitmq ctl.te, and then checking the module, check module -m, and then creating the module and inserting the module into kernel, and then restarting it. Finally, we check the status and report, and we add OpenStack to rabbitmq server with the password. Now let's execute the script. This will install rabbitmq and do the changes as I demonstrated in the script. So it's quite fast. All these scripts will be available in my Git repository. You can download the scripts. This is 2-node cluster setup. Remember, team, we'll be setting up controller and compute node in just flat 55 minutes. You'll get everything up and running. So once you download, you will be able to do it in just 55 minutes. So sourcing the file, this is memcached. Install Python 3 OpenStack client, memcached Python 3, this, and then starting it, binding the server with the IP address, and let's execute this memcached also. So this is memcached server installation, installing packages and executing the commands in the script. So this is done. Let's check the status whether memcached is running or not. Systemctl status memcached D. The server is running. Memcached is running. Let's set up the keystone. Check the file first. Same source file, path, credentials, OpenStack, functions, and then installing the packages. Setting up the database first and checking the database whether able to connect to the database locally, then checking the database connecting remote, and then installing packages. Yum install -y OpenStack keystone httpd python 3 _ -mode sgi, and then the database function and setting up the database and configuring the keystone configuration file. So this will set up the database, setting up database configurations, configuring Fernet token provider, setting up the database type, initializing the Fernet repositories, bootstrapping, and then httpd.conf file, because we are using CentOS, creating a link, and then replacing this very important point and restarting HTTPD service, and then opening it the firewall. We are creating a firewall policy also, so Linux policy, keystone HTTPD, building the policy and inserting the policy modules, and then enabling some booleans, and then setting up, setting up the environment variables, verifying, creating a service project, creating a demo project, creating demo user, creating the user role. So this is creating service project, linking user role, and then verifying the Keystone installation, requesting an authentication token as an admin user, requesting authentication token as a demo user. Let's run it, and this will step by step do all the processes. The installation of packages, and then configuring the file keystone.conf file, creating database in tables for Keystone right now, initializing Fernet key repositories, bootstrapping the identity service, starting the service, HTTP server started, building SE Linux policy module, Keystone come up, creating service project, creating demo project, creating demo user, user role, authentication tokens, and done. Keystone identity service installation done. Let's check using get auth token, and we got the token, so it is working fine. Next is glance API service. Let's verify that. So let's install. This is a script sourcing all the files, path, credentials, and functions, and then installing, setting up glance database for glance, sourcing admin credentials, and then creating user, creating a role, adding the user to the role, service creation, endpoint creation, create endpoints, then installing glance, and then database functions and the rest of the detailed setup. So configuring Keystone identity service specific details in the config file using the script, and the other sections, paste, deploy, glance store, changing the ownership and permissions, and starting the glance service, enabling firewall D, and creating the policy security enhanced Linux policy module. This is extra step required because I'm using SE Linux enabled. I've not disabled it. So my firewall is working, my SE Linux is working, and let's execute the script. So creating the user, creating service, adding the user to the service, adding the user to the role, installing packages, and configuration file created, populating the databases, verifying the service, module, SC module building, and glance started, downloading an image, and the image is created. Now we have CentOS images for testing purpose. Now the placement. Before Nova, we need the placement to be configured, same concept. I will file the symmetry. First was challenging, after that it is very easy. I modified the scripts and I made them work for CentOS 8 and Victoria. Right now we are installing OpenStack Victoria on CentOS. Check the same details: user creation, role add, service create, endpoint create. Same for placement. Adding a user, role, adding user to admin role, creating the service, then creating 3 endpoints: public, internal, and admin, and after that installing. So this is service creation and endpoint creation, and then installing OpenStack placement API, creating this file. This is important for HTTPD service. I configured it. This script is actually editing the file openstack-api.conf 00 placement api.conf file under http configuration. And then this is main configuration file, the database part, authentication part, populating the databases, and restarting the HTTPD service and restarting the other services. Execute the script. This will install and configure placement API service. And now it is restarting and it is almost done. Yes. Done. Next is the Nova controller. Nova on the controller node. Same process. Let's start from top. Sourcing the files, creating the database, setting up the database for Nova, setting up the Nova API, cell database, sourcing admin credentials, and then user create, role add, service create, endpoint create. Then installing Nova. Openstack Nova API, Nova scheduler, Nova conductor, Nova non-VPN proxy. Installing this and then configuring the main file nova.conf file. The database section, keystone authentication section, and then default section, glance API section, log directory placement section, populating the database, and then starting the service. All the services with for loop we can start. First we create a array and then we call all the services listed in the array one by one to restart and enable. Finally opening a port in firewall and then creating a Linux module and inserting it. Let's launch this. Alright, so installing. So this is creating the service, installing packages, configuring file, registering cell 0, populating Nova database, and verify that service restarted. Conductor, non-VNC proxy, Nova API, inserting the module, Linux module, checking the endpoints, and listing the image. Now let's move on to the next service, which is Neutron. We have done glance, we have done placement, we have done Nova controller. Let's start the Neutron on controller. So process remains the same, database part, and then creating user, adding user to role admin, creating endpoints, So this is adding the creating the neutron on the controller node. This is in three parts. Part 2. Look at the part 2. After sourcing the files, we are installing the packages, Openstack Neutron, Neutron ML2 and EB tables. Configuring metadata agent -ini _ini file, NOAA configuration file, creating link which is mandatory for ML2 as plugin.ini. Then Neutron for controller node. Main file is neutron.conf under etc neutron. Keystone configuration. Now this is ML2. Then we have layer 3 agent. Then we have DHCP agent. Then populating the database, enabling the firewall, creating Linux bridge CTL policy, and building and inserting the module into the kernel. Then restarting NOAA service. NOAA service, Neutron, Neutron DHCP, Neutron metadata agent, L3 agent. Verifying the operations. Let's run the script. This is populating the database now. Building the policy, inserting into kernel, restarting NOAA service, restarting Neutron service, verifying the operations. And you see all the services are up. Let's configure self service Neutron, which is Linux bridge. Openstack Neutron Linux bridge. Installing and configuring it. Installing the packages and configuring it under VXLAN section, and then restarting the services. Yes, we need to add this 99-c-ctl.conf file. This is mandatory setting, and then restarting all the services. Restarting Linux bridge. And this is a Neutron DNS mask setting. Let's run this script. So this is running. This will install the package and configure this. Restarting NOAA service. And now you will see all the agents after this service is started. Done. Now Neutron is configured on my controller node. Let's configure the dashboard, Horizon dashboard. Now this is Horizon dashboard file. Installing OpenStack dashboard Python 3 heat client. Look at the settings. etc sysconfig memcache, setting up that. Memcache settings. Configuration, cache, and creating this file. Adding this file and at the end of the config file where we specify web root, logout URL, login URL, and enables API versions. this content will be added at the backend, at the bottom of the file. And this is our OpenStack file. My time zone is Asia, Kolkata. And this is important settings we were required to set in openstack-dashboard.conf file, firewall and Apache settings. So this will set up the Horizon dashboard super fast. This is going to make your life very easy. If you want to set up a 2-node OpenStack Cloud, this will set up in just flat 55 minutes, not even 1 hour. So all the settings as per the script, verify that Apache service is running. So this part is, as you know, Horizon dashboard is also configured. Now let's look at the Cinder controller. Cinder on the controller node, image service. Oh, sorry, block storage, Cinder block storage. Same process after adding the sources. So setting up the database, creating user, adding user to role admin, service creation, endpoint creation. We are creating 6 endpoints, 3 for version 2, volume version 2, and 3 for version 3. And then installing the packages, OpenStack Cinder, setting up the things, and main file etc cinder.conf. I mean cinder.conf file, and keystone authentication details, my IP, Oslo concurrency, and the other settings. NOAA settings which are required for Cinder, and restarting the services. After that, at the end of this, firewall settings. Let's run this. So this is configuring Cinder on the controller node. After the configuration is run, restarting and enabling NOAA scheduler, NOAA VNC proxy, HTTPD restarting, NOAA API, NOAA scheduler, and NOAA conductor. After Cinder is restarted, because we made changes to NOAA.conf file, we have to restart our NOAA and Cinder services. So Cinder on controller node is done. Let's go to the compute node now. This is our compute node, and these are the scripts for compute node. So first thing is NOAA on compute node. So this is NOAA on compute node, configuring same file, except that we have only 4-5 scripts to be launched on compute node. So similar settings. This is for NOAA on compute node, configuring NOAA on compute node. Keystone authentication details section, default section, VNC section, glance section, then placement section, and then NOAA on compute, NOAA.conf file, checking that whether we have KVM or QEMU. We are using QEMU as simulator, quick emulator, restarting and building and inserting the SC Linux policy module, and then restarting the services. This is directly verifying the details from the controller node sitting here on compute node, discovering the compute node and verifying the operations, listing the services catalog list, compute service list, and finally NOAA compute status upgrade check, because this must be successful, verified to be verified on the controller node. Let's run it. So this script will do everything on the compute node for NOAA compute. Installing of packages, configuring it, restarting Nova service, building and inserting SE Linux policy into kernel, opening firewall ports, verifying that service is up and running on the controller node, and you see that catalog and the image and the policy upgrade. Everything fantastically going, all perfect so far. Let's configure now Neutron on compute. Installing packages for Neutron. On controller we need only Linux agent, we don't need anything else. Linux bridge on the compute node. Take a look of this file which I just executed. So Linux Neutron OpenStack Neutron Linux bridge, and then other sections, rabbitmq, keystone authentication, Oslo concurrency, and other things. Now we run the part 2. You see what is there in the part 2. Verifying the services, configuring Nova section, that is Nova configuration, and then restarting compute, restarting the services. Alright. Now firewall opening, building and policy, opening the boolean, and then after that verifying the details. So let's execute the script. Neutron on compute part 2. Now it is listing Neutron agents. You see all agents up. Now this is self-service. Let's check this file also. This is basically enabling the bridge and making some setting into sysctl.conf file. So this is opening ML2 Linux bridge agent file, configuring it, the public interface, plugin ML2 Linux bridge agent.ini, and then vxlan section. Let's execute this. This is done. Now this is our Cinder on the compute node. So main Cinder storage. So installing the packages. First you will see Cinder device which you are going to use SDD. That is fourth disk which we have on our machine. Alright, after that we are editing the file, installing the packages. After the packages are installed, configuration section, keystone section, LVM, other sections, and finally restarting the service, verifying the service, and we will be creating a block volume, we will be destroying it, and we will verify the working of the script by means of volume creation and deletion of the volume. Let's execute it. Now Cinder volume service on the compute node, or block volume or Cinder volume, whatever you call it, and it is up and running. Now we are just trying to create one sample, and it's created, verifying it is available, and you will see it is available. After that, yes, it is available. Now we are deleting it, verifying that it's gone. So Cinder service is also completed. We are just verifying the service once again, just in case after we worked. So let's restart. If any service is down, we are restarting and verifying again. So Neutron service was dead, we just restarted it again. We can verify again and again. Same way, Nova Compute is up and running. So let's go back and check the other services now. Cinder service also, let's verify, and it is running. Let's go to the controller node now. So this is our controller node. Now we are going to verify the services. If required, we will restart systemctl, restart OpenStack, Nova, all services, put star to restart all the services, starting with the OpenStack-Nova, and check the status. All the services are running. Nova API, Nova VNC proxy, Nova conductor, and finally Nova VNC proxy and scheduler. Similarly, let's check the Neutron services also. Neutron services, all services running. Restarting Neutron services. We are just now verifying everything configured, but we have one more service to configure. We'll do that also. Let's check that. That is orchestration service. So after all the services are up and running, and we are verify that Neutron and similarly OpenStack Cinder also. Verify that Cinder API scheduler, Cinder scheduler, and Cinder API, both services are running. And memcached service, if you want to verify. So it is running. Now let's check the heat controller on the controller node. Process remains the same after sourcing all the files for our variables. We are setting up the database, we are setting up the services, database setup details, user creation, role, adding user to the admin role, endpoint creation, and then creating the heat domain, creating heat domain admin user, heat orchestration service we are talking about, and installing packages for heat. These are all packages required for heat. Mind it, we are also including the packages in the command required to display heat in dashboard. By default, is not available in any documentation. So configuring that, and then creating the database, and this file line sudo cp you see here just above this is copying all the files, and after that we are restarting. Let's run the script. So this is creating user, creating heat and heat CFN service entities, endpoints, heat domain admin user, heat stack owner, heat stack user role, installing packages. After packages are installed, configuring settings as given in the file, and restarting the service. Now restarting the heat service, heat engine. Successfully started. Waiting for stack list, listing service components, and you see heat engine, all services up on the controller node. Let's restart our HTTPD service. Now we can verify all these on our dashboard. Let's launch a instance. This is instance launch. Requesting admin credentials, Neutron agent service. This is a script which will launch the instance, a demo instance using CentOS image. So this is verify all the networking details. So after all networking specific agents are up and running, DHCP namespace, bridge, after all these things are ready, it will start. But before that, we must configure public and private networks. So we need to do that first. This is configuring public network. Creating a public network. So public network created. DHCP agent. Waiting for the bridge to show up. And this is private network. This will create the private network. This is a script for creating private network demo, because this will be creating as a demo user. So creating, verifying. So this will create private network or self-service network. Let's take a look at the script. You can pause anytime to see the content, and the repository will be available on GitHub. You can download and use the script for your own purpose to set up the 2-node Openstack Cloud. Let's execute it. This will configure a private network. Configuring private network. So private network configured. We'll verify the ping command to our private network and public network. We need the router details for that. So let's use ping command. The IP address of our router is required. This is IP 203.0.113. So ping command for private and public, and we are able to get the ping command. So we are reachable. Let's launch the instance now. This is our dashboard, Horizon dashboard, and this is restarting OpenStack Nova just to verify once again, because we should not get any problem when we are launching the instance. Because we configured heat orchestration service, so we are just restarting the services OpenStack Nova, OpenStack Neutron, and HTTPD, verifying the status also. Verifying Cinder service. All services up and running. memcached, perfect. rabbitmq server, perfect. Launching the instance. This script will launch the instance in private subnet. As an admin user, I'll be verifying, and it will create the flavor, it will create the key if it is not available. So everything will be done by the script. Now everything is up. Checking the flavors, images, Neutron agent, and you see this is our dashboard. Let's launch the dashboard instance at the dashboard also. So this is instance. Let's launch. We are creating two instances, one from the command line, one from that dashboard. So this is our orchestration. Let's go to the instance and launch it. This instance being launched here, and this instance being launched here. Let's type this instance 1. Description demo instance. Next. Use CentOS image, nano flavor. All good. Launch it. So this will launch our instance. So two instances we have launched, one from the console, one from the command line. So we can verify the instances now. We should be able to see both the instances here. Yes, both the instances, one is in build state, one is active. Let's look at the console. This is our console coming up. Let's go on the compute here also, the one which we launched under project compute instance. Here we will see our own instance, and you can see this is the launch instance we launched. This is active. Let's see the console again. Hope it is available now. We need to log in at least. Console. Yes, we got the login prompt. Let's log in. CentOS is the user, go cubes go is the password, and we got that. Fantastic. Our console, our instance is launched. We can switch to root user also. Sudo su hyphen can be used to switch to root user, and we are good. So this training was brought to you by the Skillpedia. The Skillpedia, the website is skillpedia.co. Let me show you the website, and the course is available under Skillpedia. Skillpedia.co is the website. Join any course, the content, the images, and the lab assignment you can get on this website. I'll just upload this on this website, and you will be able to get this. These are the courses which I offer on my website, skillpedia.co. You see, SUSE administration, OpenStack, Oracle Cloud certification. These are the courses, and this is me. So a lot of courses available here. All high-end technologies based on my 30 years of experience. I have spent 30 years in IT sector, and I deliver training on many technologies including DevOps and cloud and Linux. My favorite are DBMS, Cloud, and Linux. These are my favorite technologies. Alright, so if you look at the other courses also, so just visit the website, check the courses of your choice, and if you want discount, I can offer you flat 50% discount if you are interested in any of the course, just because you watched this lecture till the end, and this nobody else will know. How? Just drop me a message in the comment. Thank you so much for watching. I hope you enjoyed my entire lecture configuring OpenStack Cloud in just flat 51 minutes, 55 minutes to be precise. Alright, thank you so much. Bye bye.